Good afternoon, morning, or evening. How you all doing today? Welcome back to Mr. Morrow's geometry class. We're going to wrap up 1-2 today, but before I do that, let me just give you a quick summary of what we did yesterday, where we went, just to make sure we're all sharp, and then we'll get to the good stuff. We were talking about distances of segments and lines and angles and all that good stuff. And when we're talking about distances of segments, especially segments, there is a nice little formula that you can use, and it is the small value minus the large value, an absolute value. Okay, that's always going to give you the accurate distance. For example, we saw the ruler that we have down here. If we go ahead and calculate that, that's going to be 6.5 centimeters. That is the distance, okay, between 5 to 11.5. If you wanted to prove that using a little formula, it'd be very simple. You would take the small value, in absolute value, you would take the small value, which is 5, minus the 11.5. That gives you the absolute value of negative 6.5, which the absolute value of negative 6.5 is 6.5. I know it's pretty rudimentary, pretty simple. When we're talking about large distances, this little tiny formula really helps out a lot. Then we discuss protractors, okay? Protractors, like the one below, are used to find angle measures. And instead of me showing you how to go through it again, I'm going to show you the different types of angles that we discussed yesterday via the protractor. So an acute angle, we said yesterday, gentlemen, was an angle that is less than or equal to 90 but greater than 0. So for example, oh, sorry, hold on. That was a fail. Let me go here. So like that would be an acute angle, okay? Notice that if we're starting from the right-hand side, we're reading the top numbers, okay? These top numbers. We talked about that yesterday. Hopefully that makes sense. Okay, if we have an obtuse angle, what's an obtuse angle? It's going to be greater than 90, but less than 180 though, guys. I don't want you to make that mistake. Sometimes people have that mistake. You got to say it's less than 180, okay? If I'm right at 90, what would that be, gentlemen?
A right angle.
That'd be a right angle. Oh, that's 89. There we go. So that'd be my 90, okay? And a straight line would be 180 degrees. Bam, right there, 180. Okay, so nice and simple, easy as pie. Okay. Now, as we continue, we already just went over all of these. Acute, again, between 0 and 90. Right is exactly 90 degrees. Remember that a right angle is indicated by that little symbol. It's a little square at the bottom corner. Remember, you cannot assume that it's 90 unless that is there, please. An obtuse angle, greater than 90 but less than 180. And then we have a straight line, which is exactly 180 degrees, and it's just literally a straight line. Okay? Okay, and then we started the parts of the degrees, and this is where I kind of rushed through it, so I want to really take my time today and make sure that you have this down pat. All right? When you're talking about a degree, guys, you got to think about revolutions. Think about a clock or an engine, perhaps the gears on your bicycle or on a moped or on a motorcycle, the 4-engine stroke on a motor for a boat or for a scooter or a motorcycle. All of those engines have moving parts, and they move in degrees. But when they're moving, there are parts of degrees, okay? A degree is really made up of a degree, minutes, and seconds. And these facts are very important for you to memorize. 60 minutes, which is denoted by just a single apostrophe, equals 1 degree. So if I've gone 60 minutes, I've gone one full revolution. In other words, I've got 1 degree. 60 seconds is denoted by the quotation marks here, okay? And 60 seconds equals 1 minute. Now we're converting each measurement into degrees and minutes here, okay? A lot of times, especially in more advanced mathematics, especially engineering and trigonometry, you have to be able to go from degrees to minutes or minutes to degrees, degrees to minutes and seconds, seconds and minutes to degrees. You got to be able to toggle between all of these. So when you're converting from degrees to minutes and you have part of a minute, a fraction of a minute, a percentage of a minute represented in decimal form or fraction form, always multiply, okay, multiply the fractional part of it, the fractional part, by 60 minutes. Literally, it's that simple. So 87.5 degrees, you take that fractional part, which is a half, you multiply it by 60, that's going to be 30. So I've got 87.3 degrees. Does that make sense? Okay. Same thing with the next one. If I've got 60.4, well, 0.4 times 60 is going to be what, gentlemen? 60 times 0.4. What's that going to give you? 24. That's exactly correct. Thank you. So, and actually, wait. Hold on. I'm getting all nervous, and I got to just chill. 87.5 degrees is not 87.3 degrees. Okay? I made a very big error there, and I'm sorry. I'm going to relax. It's 87 degrees and 30 minutes. I truly apologize. I've got to focus. Okay, sorry about that. So for number 2, 60.4 degrees, we're looking at 60 degrees and 24 minutes. Because 0.4 of a degree is the same thing as saying 24 minutes. 90 degrees, okay, we talked about 90 degrees yesterday. If I want to express it solely in degrees and minutes, it would be 89 degrees and 60 minutes, because 60 minutes is 1 degree. You add it to 89, that's 90. 180 could be 179 degrees and again 60 minutes. Now, if I wanted to expand that into seconds, what would it be, gentlemen? Sir? 179 degrees, 59 minutes, and 60 seconds. Correct, sir. Excellent. Because that 60 seconds is one minute, and that 1 minute makes the 59 60, and then if that makes the 60 minutes is 1 degree, which you add to the 179, so that's 180 degrees in total. Now, when we're going the reverse way, you're going to reverse the math. You're going to go ahead and divide by 60. So 45 over 60 is 3/4, correct? So you could do, so you can say this is 60 and 3/4 degrees, or 60.75 degrees. So when we're going from degrees and minutes, you're going to go ahead and divide by 60 minutes. How about 35 degrees and 40 minutes? 40 over 60 is 2/3, correct? That's 0.6 repeating. You don't really want to use a 0.6 repeating when you're converting these, so you can just go ahead and say 35 and 2/3 degrees in total. Okay? Now, One thing that I don't have here, but I want to make sure you guys really understand, what happens if there's seconds, okay? Let's say that I give you 42 degrees, 25 minutes, and 40 seconds. If I want this all in degrees, please be cognizant of what I'm about to do. The 42 stays the same, but the 25 minutes has to be divided by 60 minutes. And these 40 seconds has to be divided by 3,600. Now, I know that yesterday the bell was ringing right when I was explaining this, but think about it. Think about it just with regular time. Aren't there 60 minutes in 1 hour? And there's 60 seconds in 1 minute, correct? So in 1 hour, aren't there 3,600 seconds? Same thing here. If there's 60 minutes in a degree and there's 60 seconds in each minute, then that means there's 3,600 seconds in 1 degree. Does that make sense, gentlemen? Promise? All right. So let's go ahead and do the calculations here. We got 42 degrees, and then 25, over 60, and then you would add that to 40 over 3,600. I'm going to go ahead and cheat and use a calculator. So I got 25 divided by 60. That'd be 0.416. Repeating. So that's 0.41. We'll call it 7. And then we have 40 divided by 3,600. And that's 0.001. So plus the 0.001. So in total, this would be 42 plus 0.417 plus 0.001. So this would be 42.418 degrees. Really ugly numbers. If I were to give this to you, I promise you, you will be able to use a calculator as well. Okay? But I want to make sure that you understand the concept here. So we're good here? So degrees to minutes, divide by 60. Seconds to minutes, divide by 3,600, please. Yes, sir. The question was, am I ever going to have minutes or seconds alone? Not usually, because if you think about it, if it's just a second, it's so infinitesimal. It's just so small. But yes, I could do it to kind of like trick you. If I said, oh, you know, this this engine moved 30 seconds, then yeah, you can divide 30 by 3,600, and it will be a decimal, of course, but it will be a decimal with a degree sign on it. So you're 100% accurate. Thank you so much. All right, guys, so let's do it. You guys do it on your own now. What about 41 and 2/5 a degree? How can I turn that into degrees and minutes? What would that answer be, gentlemen? Yes, sir. 41.4 degrees, correct? But I want it in degrees and minutes, please. Yes, sir. That's exactly right. 41 degrees and 24 minutes. Very good. And good job for you, my man. It was good that you converted to a decimal, but you got to remember, you got to actually convert it to the degree. Now, here comes the fun part, okay? And this is pretty easy if you just think about what we were just talking about. They tell you that ABC is a right angle. Not only do they tell you, but you have a symbol here, that little square in that angle that lets you know, hey, reader, this is 90. And they say that ABD is 67 degrees, 21 minutes, and 37 seconds. They want to find angle DBC. Well, let's look at it this way. You know that we're going to have to subtract the 67 degrees, 21 minutes, and 37 seconds from 90 degrees, correct? Right? Okay, so let's do that. So we've got 90 degrees, which we can convert into minutes, degrees, and seconds. So let's do that. It would be 89 degrees, 59 minutes, and 60 seconds. Minus 67 degrees, 21 minutes, and 37 seconds. Now it's just subtracting. Please subtract seconds from seconds only. Minutes from minutes only. You don't have to do any more borrowing. We already did all the borrowing we had by converting. That's where a lot of students of mine get a little bit confused. We already converted it. Now it's just plug and play. So this is going to be the 23 seconds, 38 minutes, and 22 degrees. Does that make sense, boys? All right. How is it not going to be 23? Yes, it is 23. Yes, 60 minus 37 is 23. Yes, sir. Thank you so much for caring. Not bad, right? Okay. May I continue? Okay, awesome. Thank you. Let's do it. Okay. Now, there's going to be a lot of questions, okay? I've even seen a couple on the SAT, that they're going to give you a clock face. I know that we are in a digital world. We have a digital clock here in class. Most of you have digital watches, if you even have a watch, because the iPhone or the smartphones have a digital clock as well. But unfortunately for you guys, we're going to have to learn how to convert time into degrees, minutes, and seconds. So when we're looking at a clock face, I want you to remember, please, that 1 minute on a clock equals 6 degrees. And every 5 minutes then would equal 30 degrees. Now, I came up with 2 formulas. I hope that you're going to be able to understand them. It's pretty simple, and it's a lot less convoluted than what the book shows or teaches. So if I just give you hours only, for example, I tell you, find the degree measure of the clock face when it's 2 o'clock or 5 o'clock or 10 o'clock or 12 o'clock or 1 o'clock. If it's just hours, I want you please to use that formula. 1/2 of 60 times h, where h is the actual hour that is given. Sir, I'm going to show you where to apply it now. When you're given a clock face, and let's say it's 2 o'clock or 3 o'clock or 7 o'clock or 8 o'clock or 9 o'clock, on the dot, sharp, you use this formula to find the degrees. Okay? When you're given hours and minutes, this one's a little bit more convoluted, so please pay attention and ask all the questions you want, please. It's going to be 1/2 of 60 times the hour hand plus the minute hand value. Once you find that answer, you put it back into an absolute value, okay? And it's the answer that you found minus the minute degree total. So go ahead and write that down, please. It's 1/2 of 60 times the hour, whether it be 2 o'clock or 3 o'clock or 4, plus the minute value. That answer you put into absolute value, and you subtract it from the minute degree total. Now, the best way to do this is to actually practice. May I? I'm sorry. You got the formula, guys? Okay, thank you. Okay, so let's do it. Find the angle formed by the hands of a clock at each time. Well, for A, I tried to do the best that I could here, guys. It's 4 o'clock sharp. So this is simply going to be 1/2 of the absolute value of 60 times the hour hand value, which is 4. And that's 1/2 of 240. So this will be 120 degrees. Pretty simple. Pretty simple. Does that make sense? Okay. And if you can also think about it, every 5-minute interval is 30 degrees, right? Well, you had 1, 2, 3, 4 of those intervals. 4 times 30 is 120. So for the hours, it's nice and simple. You can just count it up, or you can plug it into the formula. Now, for B, it's a little bit more challenging. B, it's 220. So let's go ahead and take 1/2 the absolute value of 60 times the hour hand value, which is 2, plus the minute hand value, which in this case is 20. Okay? 60 times 2 is 120, plus 20 is 140. Divided by 2 is 70. So now you take the absolute value of your answer, which is 70, okay, minus the minute degree total. How many total degrees are there in 20 minutes? If every 5 minutes is 30, guys. 40? No. 120. Very good. So 70 minus 120 is negative 50. Absolute value of negative 50 is 50 degrees. And if you think about it and you look at the clock face, it makes sense. Between 3 and 4, that's 30 degrees, right? And then from 2 to 3 is 30 degrees. But I already went 1/3 of the way of the clock. So what's 1/3 of 30 degrees? Guys, what's 1/3 of 30 degrees? 10. Okay? So that's where we're going to get. You have the 2/3 left. So that's 20. That's 20 degrees. 20 plus 30 would be the 50. But I don't like that way. That's how the book teaches it. So I came up with this little formula. Does that make sense, gentlemen? All right, let's do another one. Let's say it's 5:15. Okay, we got 1/2 of 60 times the hour hand value, which is 5, plus the minute hand value, which is 15 here. That's going to equal 315. 315 divided by 2 is 157.5. Minus the degree total of the minute hand. If it's at 15 minutes, guys, how many degrees is that? Remember, every 5 minutes is 30 degrees. 90. So 157.5 minus 90 in absolute value will equal 67.5 degrees. That's exactly perfect. Excellent job. Now I want you guys to do 11:30 on your own for a second. Okay? I'm going to pause the video. Okay. Let's see if we got that answer. First of all, my friends, it's going to be the 1/2 of the absolute value of 60 times 11 plus the minute hand value, which is 30. Okay? 60 times 11 is 660, plus 30 is 690. Half of 690 is, in absolute value, 345 minus the degree total for the minute hand. If the minute hand is at 30 and every 5 minutes is 30 degrees, that means there's 6 sets of 5. 6 times 30 is 180. So 345 minus 180, that will equal 165 degrees. Does that make sense? Yes, sir. Yes, sir. Yes, you could, of course. Of course, what my boy said was, it's easier for me to think of a circle as 360 degrees and then work backwards. That's fine. That's fine. Okay, now it's very easy when they're nice and pretty like this. But the formula is really useful when it's something like 1227. That's when the formula really comes in handy, right? Okay? Yes, sir.
You want us to memorize these formulas, or are you going to put them on test?
Yes, please. I want you to memorize the formulas. Thank you so much for asking and caring, sir. Any questions on that? Any other questions, rather? Did you understand what you did, Rama, man? Thank you, sir. All right, brothers. Now, Let's talk about congruent angles and segments. Congruent angles and segments. Congruent is symbolized by that, guys. If you have congruent angles or segments, that means that they have the same measure or length. That's all it means. Congruent just means it's the same measure or the same length. So if, for example, I tell you that the measure, by the way, let me explain that. See this little M here in front? That represents measure of an angle. That little M just represents the measure of angle A. This little M over here represents the measure of angle B. So if I tell you that the measure of angle A is congruent to the measure of angle B, then they can be represented as followed using tick marks. This is very important, especially when you see figures on tests, not just mine, but the SAT, ACT, stuff like that. See how I have a little curve there, and then I put one little curve here? One curve to one curve, that means that they're equal. You cannot make them different because that means they're not equal. If they're equal, they're going to have the same symbol on both. I call them tick marks. For example, same thing with segments, gentlemen. If I tell you that segment AB is congruent to segment CD, then they can be represented as follows. I could do, for example, that and that. Or I can do a double, and then I put a double. I can make pretty much any symbol that I want as long as it's replicated with the other congruent part. Okay? Now, with that in mind, talk to me. Name some congruent parts of the figures below. Okay? So as you see them, you could just shout them out. What you got here, guys? What do we got? Yes, sir. Okay, how can a segment be equal to an angle? No. No, don't worry. Thank you.
Angle B and angle C.
There you go. Thank you, sir. So angle B would be congruent to angle C. Sir. No. Angle A and angle D don't have any symbols, do they? No, no, no. I thank you so much. That's why I did this. It's so important to realize that. In geometry, that's one thing. There are very few things that you can assume, and we're going to go over that in the next lesson. But unless they have a tick mark, you can't assume that they're congruent, my brother. Thank you so much. Yes, sir. Angle F, and yes, on two different triangles, but absolutely, angle F would be congruent to angle I. Absolutely. Yes, sir. Very well done, sir. Segment AD is congruent to segment FG, which is, that looks like a 6, sorry, which is congruent to segment HI. Absolutely fantastic. Yes, sir.
Segment FE.
Uh-huh.
Segment JI.
Segment FE is congruent to segment JI or IJ. It doesn't really matter how you read that. Fantastic. Excellent, gentlemen. Okay, any questions? Then we're golden. Thank you very much, and I hope you learned a lot.